Hello grade 11s and welcome to another lesson on physical sciences. Right now we are going to be dealing with power and energy. Here we go. So just take those questions down, please. So, number 1 asks, what does a cell convert chemical potential energy into in a circuit? So, the cell converts chemical potential energy into electrical energy. Number 2 asks, what do we call the rate at which work is done? So, power is the rate at which work is done. What is the basic unit of power? So the basic unit of power, or the System International SI unit of power, is the watt, capital W. What do we call the rate at which electrical energy is converted in an electric circuit? Power. So power is the rate at which work is done, or the rate at which electrical energy is converted in a circuit. Now number 5 states, given the circuit component that has a potential difference of 3 volts and the resistance of 4 ohms, what is the power dissipated by the circuit? So you're looking for P, right? We are given that the potential difference is 3 volts and the resistance is 4 ohms. So we take the formula which states power is equal to V squared over R. It's in the information sheet because we have V and R, right? So it is going to be, what is V? 3 squared over, what is R? 4 ohms. So power is 2.25 watts. Number 6 states, in a simple circuit, the resistance of a resistor is 2 ohms and the current going through the resistor is 6 amperes. What is the power for the resistor? So once again, we are looking for power. We are given that the resistance is 2 ohms and the current is 6 amperes. So we go to the information sheet, the formula which has I and R. So P is equal to I squared R. What is I? 6 amperes squared. What is R? 2 ohms. So power is 72 watts. Number 7. What is the power of a 5 megavolt lightning bolt having a current of 8 kiloamperes? So we have the potential difference. Okay, once more, we don't know the power. The potential difference is 5 megavolts, right? We know that it's supposed to be in volts. Mega is 5 times 10 to the power of 6. Mega is million volts, right? And then current is 8 kiloamperes. We know that kilo is 8 times 10 to the power 3 amperes. The formula that has V and I, so P is equal to VI. What's V? 5 times 10 to the power of 6 volts. What is I? 8 times 10 to the power of 3 amperes. So it's 5 times, oh my, 10 to the power of 6. Oh my, it's supposed to be times. Four times 10 to the power of 10. So power is 4 times 10 to the power of 10 watts. Or you can write it as P is 40 gigawatts. It's still fine. Number 8 states, how many watts does a torch that has 24.3 kilocoulombs pass through it in 0.75 hours use if its potential difference is 7 volts? Wow, okay, this is hard. We don't know the power. We only know that charge, which is Q, is 24.3 kilocoulombs, which is 24.3 times 10 to the power 3 coulombs. Then we know that the potential difference is 7 volts. Time 0.75 hours. The SI unit for time is the second, so it's going to be 0.75 times hours times 60 minutes per hour times 60 seconds per minute. So it's 2,700 seconds. So we have time. In the information sheet, there's a formula which says I is equal to Q over delta T. Let's use that to find the current first. So what's Q? It's 24,3 times 10 to the power 3 coulombs over time is 2,700 seconds. So we have I is 2,700. Current is 9 amperes. We have this and we have this. So we can use the one which has V and I. P is equal to VI. V is 7 volts. I is 9 amperes. 7 times 9 is 63. Power is 63 watts. Number 9 states, find the power dissipated by an extension cord with a resistance of 11 ohms when a current of 10 amperes flows through it. P is unknown as usual. We have this, so the resistance is 11 ohms. Current is 10 amperes. I and R. P is equal to I squared R on the information sheet. What's I? 10. R is 11 ohms. So we have P is equal to 1,100 watts. Number 10. Calculate the power dissipated by an electric heater with a potential difference of 20 volts and a resistance of 12,5 ohms. Interesting. So once again, P is unknown. V is 20 volts. R is 12,5 ohms. We have V and R. The formula which involves V and R for power is P is equal to V squared over R, which is, what is V? 20 volts squared over, what is R? 12,5 ohms. So P is 32 watts. The last question for now asks you, determine the power dissipated by a cell phone with a voltage of 13 volts when a current of 12 amperes passes through it. So once more, P is unknown, voltage or potential difference is 13 volts, current is 12 amperes. P is equal to VI. What's V? 13 volts. I is 12 amperes. So P is 156 watts. Okay, grade 11s, I know that may have been a little too much, content, but that's just to get you in touch with practicing some of the formulas on the information sheet and knowing which one to use. So see you on the next segment. Thank you.